In power transmission systems, a bottleneck refers to a situation where a specific component or section of the network has limited capacity to carry electrical power, constraining the overall transmission capacity of the system. This can prevent the efficient flow of electricity from power generation plants to consumers, causing inefficiencies, congestion, and even the risk of system instability or blackouts. Bottlenecks can occur due to physical limitations in transmission lines, transformers, substations, or control systems. Transmission bottlenecks in power systems are a multifaceted issue, driven by growing demand, the rise of renewable energy, and aging infrastructure. Causes of bottlenecks in power transmission: inadequate transmission capacity. When the demand for power exceeds the capacity of transmission lines, the lines may become overloaded, leading to congestion. Old or aging infrastructure. Transmission systems with outdated or aging infrastructure may not be able to handle increased demand, especially as the grid evolves to integrate more renewable energy sources. Geographical constraints. In some cases, geographical challenges make it difficult to build additional transmission lines, especially across long distances or in areas with difficult terrain. Uneven power distribution. Some regions might produce more power than others, e.g., areas rich in wind or solar resources, but the transmission infrastructure may not be adequate to carry this power to where it is needed most. Intermittent renewable energy. The rise in renewable energy sources, such as wind and solar, has introduced new challenges. These energy sources can generate large amounts of power in specific regions, but the transmission infrastructure may not be able to handle these surges effectively. Impacts of transmission bottlenecks. Increased congestion costs. When bottlenecks occur, system operators may need to rely on more expensive power generation resources that are closer to consumers, raising the overall cost of electricity. Curtailment of renewable energy. If a transmission line is unable to carry the amount of power generated, renewable energy sources such as wind farms may need to curtail their production. Decreased reliability. Bottlenecks can lead to voltage instability, higher losses, and a higher likelihood of system outages. Energy imbalance. If certain areas cannot receive the necessary power, there can be disparities in energy supply between different regions. Techniques to solve bottlenecks in power transmission. Grid expansion. The most straightforward way to eliminate bottlenecks is to build new transmission lines to increase capacity. However, this solution requires significant capital investment and time due to planning, regulatory approvals, and land acquisition challenges. Take an example: the European Union's push for interconnection between member states through cross-border transmission lines to avoid bottlenecks and optimize renewable energy distribution. Upgrading existing transmission lines. High-temperature low-sag HTLS conductors,